On the evening of March 27, 1999, an F-117 Nighthawk disappeared from radar screens over Serbia. The aircraft the United States had declared invisible, the jet that had defined American air dominance for 2 decades, had been shot down by a Soviet-era surface-to-air missile system that first entered service in 1961. The wreckage fell across a muddy field outside Bujanovci. Within days, Chinese officials had requested access to the site. The Serbian government obliged. 12 years later, a prototype designated 2001 lifted off from a facility in Chengdu. Western intelligence analysts had not expected China to fly a 5th-generation stealth fighter for several more years. Their assumptions did not survive the afternoon. This is not a story about Chinese persistence. It is a story about attention. For 7 decades, the People's Liberation Army Air Force watched every move the United States made in the air, studied every technology Washington sold or left unguarded, and built a force that now, by any objective measure, has surpassed what most of the world believed was possible. 22 aircraft types, 76 years. And a question that nobody in Washington has answered convincingly: how much of it did America help build? Chapter 1. Korea, America's accidental classroom. The People's Liberation Army Air Force was formally established on November 11, 1949, 8 days after the People's Republic itself had been declared. It was, in every practical sense, an afterthought to a revolution fought entirely on the ground. What China had in the air in those first months was a collection of Soviet hand-me-downs and aircraft captured from nationalist forces during the Civil War. None of it was capable of threatening anyone with serious air power. That changed fast. The MiG-15, designated J-2 in Chinese service, arrived directly from Moscow along with Soviet advisors and a training pipeline built for speed rather than depth. The aircraft itself had been a shock to the Western world when it first appeared. Swept wings, a service ceiling above 15,000 meters, a climb rate that made the early American jets look pedestrian. Armed with one 37mm cannon and two 23mm cannons, it had been designed to destroy bombers. Over Korea, it proved devastatingly effective against B-29 formations, forcing the Americans to abandon daylight raids almost entirely. China entered the Korean War officially in October 1950. What followed was not just a military campaign. It was an education. Every engagement with USAF pilots over MiG Alley taught Chinese aviators something about American tactics, American doctrine, American weaknesses. By the time the armistice was signed in July 1953, the PLAAF had expanded from 2 aviation brigades to 28 full divisions operating 3,000 aircraft. Zhao Baotong became the first Chinese jet ace of the conflict. The J-2 remained in Chinese service until 1978. That same corridor of conflict also introduced China to the MiG-17, which entered service as the J-4 in Soviet-built form in the early 1950s. It was faster than the MiG-15, more maneuverable at low altitude, and still more than capable of engaging American aircraft in a turning fight. The J-4 was a bridge, a platform to keep Chinese squadrons current, while something more significant was being prepared. That something was the J-5. On July 19, 1956, test pilot Wu Keming lifted off from Shenyang in the first Chinese-built MiG-17F. It had been assembled under Soviet license using plans, pattern aircraft, and 15 knockdown kits supplied by Moscow. China called it the Dongfeng 101, East Wind 101. 767 single-seat J-5s followed. The J-5A, a radar-equipped variant based on the MiG-17 PF, added a basic all-weather intercept capability. The first time any Chinese aircraft could engage a target it could not physically see. The lesson of the Korean years was not just technical, it was methodological. You watched the Americans fly. You copied what worked. You kept building. That principle would govern everything that followed. Chapter 2. The Split, Flying Blind, Building Anyway. In 1960, the Soviet Union pulled every one of its technical advisors out of China. They took the blueprints with them, or destroyed what they could not carry. The relationship that had supplied China with its entire modern air force collapsed in a matter of months, and Beijing was left to finish what Moscow had started, or fail, trying. The most immediate casualty was the MiG-19 program. China had been producing its copy under the designation J-6, and despite the rupture, it kept going. Over 4,000 J-6 were eventually produced, making it the most numerously built aircraft in PLAAF history and one of the most exported jets to the developing world. The first production aircraft in the world capable of supersonic speed in level flight. Simple, fast, and brutally reliable. It formed the numerical backbone of the PLAAF through the 1960s and into the 1970s, and gave Chinese industry the manufacturing discipline that would prove essential for everything that came after. The deeper crisis was the J-7. China had been developing its MiG-21 copy with Soviet assistance when the advisors walked out, leaving incomplete documentation and no one to fill the gaps. The result was 7 years of delay. The J-7 finally entered PLAAF service in January 1966, a full 7 years after the original MiG-21 had been flying with Soviet forces. It was a Mach 2 capable delta-wing fighter, lightweight and agile. But by the time it reached Chinese squadrons, it was already a generation behind what American and Soviet pilots were flying. Over 2,400 airframes were eventually produced across all variants, and China kept exporting the design all the way to 2013, when Bangladesh received the final batch. The J-7 also produced a trainer variant, the JJ-7, a two-seat supersonic derivative that remained in production for decades. The last JJ-7 was delivered to the PLAAF in 2017, the same year the J-20 entered service. An aircraft lineage that began with a Soviet MiG-21 copy from the 1950s was still being delivered to Chinese squadrons in the same calendar year as China's first stealth fighter. That overlap says more about the scale of the transformation than any single statistic. The Q-5 Fontan emerged from the same era of forced independence. A ground attack derivative of the J-6, it featured a completely redesigned forward fuselage, an internal weapons bay, and twin lateral intakes replacing the nose intake of its parent design. It first flew in June 1965. Approximately 1,200 were eventually built. Unglamorous, numerous, and essential, it was the PLAAF's primary strike aircraft through 2 decades of Cold War tension. Chinese engineers had watched American ground attack doctrine develop through Korea and Vietnam. The Q-5 was their answer, built entirely without outside assistance. That same year the Q-5 first flew, China began development of what would become its first completely indigenous jet fighter design. The J-8 was conceived in 1964 as a twin-engine high-altitude interceptor, larger and faster than anything in the existing inventory. Development stretched across the Cultural Revolution, a decade in which engineers were persecuted, programs were halted, and institutional knowledge was systematically destroyed. The J-8 did not make its first flight until July 5, 1969, 5 years behind schedule. What emerged was a Mach 2.2 capable interceptor with twin engines fed by lateral intakes, optimized for the altitude bands where Chinese radar coverage was strongest. But without a modern radar, it was limited to visual range engagements. That constraint drove the J-82. The redesigned variant moved the air intakes to the sides of the fuselage, freeing the nose for a proper fire control radar. It first flew in 1984. Approximately 300 were built. For the first time, a Chinese fighter could engage targets beyond visual range, a capability that every Western fourth-generation aircraft had carried for a decade already. China had arrived, late, at a threshold the Americans had crossed years before. Chapter 3. Open Door: What Washington Chose to Sell. The late 1970s opened something unexpected: a narrow window of Western technology access, and China moved quickly to exploit every centimeter of it. Britain had actually moved first. Rolls-Royce Spey turbofan engines had been acquired by China in the early 1970s through commercial channels, before the full normalization of Western-Chinese relations. The transaction was legal. The implications were not fully considered. China used that engine as the basis for the JH-7, a twin-engine supersonic fighter bomber designed to give the PLAAF and naval aviation a genuine precision strike capability. Development was tortuous. The program stretched across nearly 2 decades. The JH-7A production variant did not reach operational units until the early 2000s. But when it did, it carried anti-ship missiles and precision-guided munitions that no previous Chinese aircraft could deliver. The first Chinese aircraft designed from the outset for the strike role rather than adapted to it. The engine that made it possible had been purchased over-a-counter in London. France followed. A 1979 agreement allowed the purchase of SNECMA turbofan engines and related technology. Chinese engineers studied them intensively, not to fly them, but to understand what Chinese power plant development was still missing. Then came the Reagan administration. The Peace Pearl program, launched in the early 1980s, approved the sale of American avionics technology and manufacturing equipment to China. The stated purpose was straightforward: modernize the J-82 with Western radar and cockpit systems, balance the Soviet threat. The logic made sense to people who believed the Cold War was the only war that mattered. American engineers traveled to China. Chinese engineers traveled to the United States. Technology moved in both directions, though not symmetrically. The program was canceled abruptly after June 1989, but the knowledge China had already absorbed did not leave with the American contractors. It stayed. It was studied. It was applied. The J-82 that emerged from the Peace Pearl era was a more capable aircraft than it would otherwise have been. More importantly, Chinese engineers had spent years inside American avionics systems, learning not just what the technology did, but how it worked and why. Washington had essentially paid for an education it did not intend to provide. Chapter 4. The Flanker: Buying Time, Buying Secrets. The Soviet Union collapsed in 1991. China moved within a year. In 1992, the PLAAF signed a contract for 24 Sukhoi Su-27 SK Flanker B aircraft at an estimated cost of $1 billion. It was the most significant single acquisition in the Air Force's history. The first time China had purchased a genuine fourth-generation air superiority fighter capable of matching Western designs on roughly equal terms. The Su-27 was extraordinary by comparison with anything in Chinese service. twin Saturn AL-31F turbofans producing over 12,000 kilograms of thrust each, a maximum speed of Mach 2.35, a combat radius exceeding 1,500 kilometers, the N001 radar capable of tracking multiple targets simultaneously, the R-27 missile family for beyond visual range engagements. Against the J-7S and J-8S that formed the bulk of the PLAAF inventory, the Su-27 was not an upgrade. It was a different category of aircraft entirely. The license production agreement followed in 1996. Shenyang would build 200 copies designated J-11 using Russian-supplied components and Russian engines. China suspended the contract after completing 105 aircraft and began building the rest with domestic components. Moscow protested. Beijing proceeded. The J-11B, which entered service around 2006, replaced the Russian AL-31F power plant with the Chinese WS-10 turbofan and the Russian avionics with Chinese systems. It was reverse engineering at industrial scale, exactly the playbook Moscow had written in the 1940s when it copied the American B-29. The Russians understood precisely what had happened because they had done it themselves. Between 2000 and 2004, China acquired 76 Su-30 MKK and 24 Su-30 Mk2 aircraft, twin-seat strike variants with improved avionics and a genuine multi-role capability the original Su-27 had never been designed for. The Su-30 MKK became the PLAAF's long-range precision strike platform for the first decade of the 21st century. The aircraft that could actually threaten surface targets at range with guided weapons, including American carrier strike groups operating in the Western Pacific. China's final Russian purchase came in 2015. 24 Su-35S aircraft, fully delivered by 2019. The stated motivation, at least partly, was the Saturn AL-41F1S engine with its three-dimensional thrust vectoring nozzle. China wanted to study that technology for its own next-generation power plant programs. The aircraft were largely a delivery mechanism for the engine data. As of 2025, the PLAAF and Chinese naval aviation operate approximately 319 flanker family aircraft across all variants, more than any country outside Russia. Chapter 5. Debris Field. The technology nobody was supposed to take. The F-117 that fell over Serbia in 1999 was not just an aircraft. It was a library, stealth coatings, faceted geometry, exhaust shielding, edge alignment principles that had taken Lockheed's Skunk Works years to develop and had never been shared with anyone. The wreckage was spread across several kilometers of Serbian farmland. Recovery was incomplete, and Chinese officials, by multiple credible accounts, were given access to what was collected. Nobody in Washington has ever offered a satisfactory public explanation for what followed. What can be documented is this. The J-20 Mighty Dragon, which made its first flight on January 11, 2011, incorporated low observable design solutions that Chinese engineers had not previously demonstrated any capability to develop. The configuration was a twin-engine Delta Canard stealth fighter with internal weapons bays, an AESA radar, and a planform that borrowed visual elements from both the American F-22 and the cancelled Russian MiG-1.44. Chinese engineers consistently assert the design evolved from domestic aerodynamic research. The timeline between the Serbian wreckage and the Chengdu flight test is a fact that analysts note without being able to disprove. The cyber dimension is documented more clearly. A 2009 breach of Lockheed Martin's networks, attributed by American investigators to Chinese state-sponsored actors, compromised data related to the F-35 Joint Strike Fighter program. The specific files accessed included information on radar cross-section management, exhaust system design, and the aircraft's duct geometry. The Department of Defense confirmed the intrusion. Years later, the J-20 displayed inlet and weapons bay solutions that bore a closer resemblance to the F-35's internal architecture than to anything previously seen in Chinese aviation. Coincidence remains the official Chinese position. The J-20 entered PLAAF service in March 2017. The first combat unit was formed in February 2018, making China the second country in the world and the first in Asia to field an operational stealth fighter. In March 2022, a US AFE-3 Sentry airborne early warning aircraft failed to detect an approaching J-20 until it was very close. The Pacific Air Force's commander confirmed the encounter publicly and described it as a genuine concern. In March 2023, Chinese state media confirmed that J-20s were being used to simulate F-35s in opposing force training scenarios, an indication that the PLAAF considered its own aircraft a credible stand-in for the most capable Western fighter in service. From 50 airframes in 2020, J-20 production reached 300 by mid-2025, a five-fold increase in 5 years. The J-20S, a twin-seat variant, began appearing in 2021. It is widely believed to be configured for controlling autonomous wingman drones, a role that places it at the leading edge of a new doctrine of manned-unmanned teaming that no Air Force has yet fielded at scale. The J-35A completes the picture. China's second fifth-generation fighter, officially unveiled in late 2024 and now believed to be in serial production, is a lighter complement to the J-20 designed to operate alongside it and to equip Chinese aircraft carriers in a naval variant. A single country fielding two simultaneous fifth-generation production lines, one heavy, one light, is something that has not happened outside the United States. Chapter 6. Made in China, the part that worries Washington most. The J-10 program was launched in February 1984. The requirement was straightforward in concept and nearly impossible in execution. China needed a fourth-generation multi-role fighter it had designed and built entirely on its own. 3 design institutes competed. Chengdu's Delta Canard proposal was selected, a configuration whose aerodynamic resemblance to the Israeli Lavi would generate controversy for decades, though both governments consistently denied any connection. Development took 14 years. American spy satellites first photographed J-10 prototypes at the Chengdu facility in 1994. The Chinese government said nothing. The first successful test flight did not occur until 1998, and it required a Russian-supplied Saturn AL-31FN engine to get off the ground because China still could not produce a competitive domestic turbofan. The J-10 entered service in 2004. China officially acknowledged its existence in 2007. The J-10C, the most advanced production variant, carries an AESA radar, the Chinese WS-10B engine, and the PL-15 Beyond Visual Range missile with a quoted range exceeding 200 kilometers, longer than any equivalent Western weapon currently in service. In 2025, Pakistan claimed a J-10C achieved an aerial kill against an Indian Rafale using a PL-15. The first claimed combat kill by any Chinese-designed fighter in history. The aircraft that Washington had spent years dismissing as a copy of someone else's design had just demonstrated that its primary weapon could reach targets that could not reach back. That same productive discipline was applied in parallel to what would become China's most prolifically produced modern fighter. The Shenyang J-16 entered PLAAF service in 2015, derived from the J-11B twin-seater and closely related in concept to the Russian Su-30. It was designed as a true multi-role platform. Air superiority, precision strike, anti-ship, and electronic warfare, all from the same airframe. By 2025, approximately 450 J-16S were in service, the fastest production ramp of any Chinese fighter in history. The J-16D is a separate story, a dedicated electronic warfare variant that first flew in December 2015. It replaced the air-to-air missiles with jamming pods and anti-radiation weapons, giving China its first airborne electronic attack platform, the equivalent of the American EA-18G Growler. In 2022, a J-16D intercepted an Australian P-8 maritime patrol aircraft over the South China Sea and released a bundle of chaff that was ingested by the P-8's engines. The incident became a diplomatic flashpoint. It was also a demonstration of exactly how the J-16D is intended to be used. These aircraft, the J-10, the J-16, the J-20, the J-35A, are not derived from foreign designs. They are not reverse-engineered from purchased hardware. They carry Chinese engines, Chinese radars, Chinese missiles, and they were built by Chinese engineers working from Chinese research. That is the development that analysts find genuinely difficult to account for, and the one that makes the stolen technology argument feel, in retrospect, like the less alarming half of the story. Chapter 7. The Numbers. What 2025 actually means. In 1950, the PLAAF had fewer than 100 fighters. In 1954, it had grown to 3,000 aircraft. In the decades that followed, it shrank, stagnated, and modernized in fits and starts, constrained by politics, by the Sino-Soviet split, by the Cultural Revolution, and by an industrial base that consistently promised more than it could deliver on schedule. What changed was pace. Between 2016 and 2022 alone, the PLAAF incorporated over 600 fourth and fifth generation aircraft into more than 19 frontline combat brigades. By 2025, China had overtaken Russia in total combat aircraft. 1,583 against 1,522. The J-20 fleet stood at 300, the J-16 fleet at 450, the J-10 at 550. Those three types alone represent over 1,300 modern combat aircraft, all domestic, all equipped with Chinese engines, Chinese radars, and Chinese missiles. In 2024 and 2025, multiple examples of two different tailless flying wing prototypes were observed at Chinese test facilities. Designs that analysts have labeled sixth generation. China is the only country besides the United States with confirmed next-generation manned fighter prototypes actively flying. The American equivalent program, Next Generation Air Dominance, remains in development. The PLAAF that went to Korea in 1950 with borrowed Soviet jets and pilots trained in months is gone. What replaced it followed a trajectory that ran through 22 aircraft types across 7 decades, using every method available. Licensed copies, reverse engineering, technology purchased from willing governments, intelligence operations against unwilling ones, and eventually, genuine domestic innovation at a scale that nobody predicted. The J-2 over the Yalu, the J-5 rolling out of Shenyang, The J-8 delayed by a decade of political catastrophe. The flanker purchased out of strategic necessity. The J-10 acknowledged only after it was already flying. The J-20 delivered ahead of schedule to an air force that had learned, finally, how to build what it needed. Some of what it needed, Washington provided. Some it took. Some it built from nothing. The next time an American aircraft fails to detect something that should be visible, the question will not be where China got the technology. The question will be what they have built since,